Okay. All right. So today we're talking about exceptions. All right. So I'm going to start off by just writing a very small program. Okay. And this isn't even going to be anything with classes or anything like that yet. Okay. So, oops. VI. Sure. 13. Okay. So suppose that I have this following program. I'll have A equals 5, B equals 3, C equals 0, and D equals 9. All right, so we'll do print A plus B, print B plus C, print A times B, print C divided by D, and print B divided by C, and print A minus B. Okay, so I just have a bunch of, now I guess I'm probably going to need to put in straws for all of this to make sure that this actually works. So let me do that. So again, we're not doing anything interesting here. I just am creating this to demonstrate a point. Okay. So when we run this program, we see, okay, well, if we print out A plus B, we expect this to print out 8, and then we expect the next one to print out 3 plus 0, which is 3, and etc. But when we get down here to this line, B divided by C, okay, B is 3 and C is 0, okay? So you can't do dividing by 0. 3 divided by 0 gives an error, okay? Division by 0 error. And so what we expect to happen is that this program is going to crash at this line right here, and it will never actually execute the A minus B. And in fact, if I were to put more lines down here, like maybe I'll do B minus B, sure. C minus D, okay. Basically, what we expect to happen is that none of these 3 lines right here are ever going to get executed, okay? Because the program is going to get here to this 3 divided by 0. It's going to crash. So we'll get something printed out for this line, this line, this line, and this line. And then when it gets to here, the program is going to crash, and it'll never actually print out the rest of the program. Okay, so let's actually see if that in fact happens. Okay, so I'm going to do Python 3, lecture 13. Okay, and sure enough, that's exactly what happened. Okay, it printed out the first 4 items that we expected here. So it printed out the A plus B, the B plus C, the A times B, and the C divided by D, 0 divided by 9. But then when it got to here, it just crashed and gave us this 0 division error, division by 0, okay? And it never actually executed the rest of our statements, okay? So the reason why you have this idea of exceptions and exception handling is to deal with errors that might arise in the normal execution of a program in such a way that your program doesn't just crash and stop running, okay? So here's another thing that I can do, okay? Suppose that I were to comment this line out, but in its place, I said, all right, I'm going to try and open a file. And there, that's the file that I'm going to open, all right? Now, if that file doesn't exist, okay, watch what happens. Okay, same deal. Now, it executes those first 4 statements and prints them out, but then it tries to open this file and I get this file not found error because I don't actually have a file named that anywhere. Okay, but as a result, the program just crashes and I never actually get to execute the rest of my program. Okay, so exception handling and exceptions is all about dealing with these situations that can occur. Okay, so the first thing that I'm going to do is I'm going to show you how to handle some of these exceptions. All right, I'll comment this one out for a second. All right, so what I can do is for a group of statements or for a single statement, I can enclose them in a try-catch block. Okay, And so I'm going to show you some different ways of dealing with it. Okay, in this case, what we'll do is we're just going to put this one statement inside a try. It's actually called a try except, but in other programming language, they call it a try catch. So this is the syntax. It's just try and then colon, and then we're going to indent all the statements that we want to try to do. Okay, and then except with nothing says, all right, if when you run this code, it generates any kind of an error that would just cause the program to die, then immediately go down here into the except line, okay, and do whatever it says. So we, in this case, maybe we'll just say print, there was an error. Okay, and then resume the program after you're done with the except statement, okay? So in other words, what we expect to happen now is it'll execute these first 4 lines. It will try and execute this, but you'll get, this will throw that 0 division error, okay? And so that'll jump the program execution down to here. It's going to print out, instead of trying to actually do this and then just crashing, it's going to jump out to here, say there was an error, and then the program will continue running, and so it will print the remaining 3 lines, okay? And so let's go ahead and demonstrate that. All right, and so sure enough, we see that it executed those first 4 lines, then it printed out, oh, there was an error, and then it went ahead and finished running the rest of my program, okay? All right, now, I can put one statement in here, okay? So for example, I could put in another statement here. Actually, in this case, I'm just gonna, I'll just print out a message saying just finished the exception stuff. Okay, because I want to show you this. All right, so and this is important to understand, is that the way the program execution flows is it'll execute these 4 statements. It's going to get into here. If at any time I hit an exception, okay, then I'm going to immediately cease doing whatever's in the try block and skip over to the except block, okay? So what should happen is when I try and do b divided by c, I'm going to get that 0 division error. I'm immediately going to jump down into the except block. It will say there was an error, and then I'm going to go finish here with this. So in other words, this line, print just finished the exception stuff, this line should never be executed, okay? Because this is going to throw that error. The program is going to jump over it into the except block, and then it's going to finish that out and print this. So if we run this, we'll see that that in fact is exactly what happens, okay? Notice nowhere in our output did we see this line just finished with the exception stuff, because it threw the exception was raised here, and then it immediately left everything inside that try and went down into the except, okay? One of the things that you have to keep in mind when putting your code in try except blocks is that if all of these statements can throw exceptions, then you might need to have separate try except blocks, okay? So let me demonstrate what I mean by that. Suppose that instead of this, I said, all right, after the b/c, let's do a/c. So let's try and do 5 divided by 0, okay? We'll do 5. Okay, yeah, I can just leave it like that, all right? So what will happen is this line will try to execute. I'll get the exception. It'll go down here. It'll say there was an error, and then it'll finish with these 3 lines. It will never execute this statement here, the 5 divided by 0, okay? So if you want this one to be included, you would then need to have a separate try catch block outside. So here, let me first save this and show you that it in fact, okay, it only says that there was the error just the one time, okay? And so what you would need to do is I would need to move this down here and put it in its own try except, okay? Like this. Okay. So now the way the flow works is it'll execute these 4. It tries to do this. If there's an error, it goes and prints there was an error. Then it goes and it tries to do this. If there's an error, it skips to the except and then prints this. And then it continues on with the rest of the program. Okay. So in this example, it should print out there was an error twice. Okay. Because both times we have division by 0 problems, okay? And I need to save this, okay? And so you see now it said there was an error twice, the way that we expected, okay? All right, so now, all right, so that's good, okay? So then the next thing that I want to talk about is suppose that there is a certain type of error that I want to catch, okay? So I'm going to modify my program like this, okay? In addition to, I'm going to take this file open command and I'm going to stick it in here, okay? Now, you'll notice that there are actually 2 different types of errors that we're dealing with here, okay? So in the first case, I have a division by 0 error, okay, the B divided by C. And in the second case, I have a file not found error, I think is what it was called. Let's see, what did they? Yeah, file not found error, okay? And so it would be nice if in my try except block, I had ways of handling the different types of errors, okay? And it turns out we do have that. So what I can do is, all right, now if I execute this code as is, again, the way the logic flows is it'll execute these 4 statements, okay? It'll try and execute this statement, generate the 0 division by 0 problem, which will jump me down here. It'll print there was an error, and it will never actually try and do this file open, okay? So here's what we can do, is we can actually put in multiple except blocks and we can specify the type of exception we want to handle, okay? So what we'll do is instead of just doing except colon, we're going to say except, and then we'll do 0 division error, and then we'll just call it E, okay? So we need to specify the type of exception, okay? In this case, is 0 division error, and then we need to give it a variable name, okay? And the only reason why you give it a variable name is so that you can use attributes and methods of this variable should you want to, okay? But we're going to go ahead and say print there was an, we'll say there was an error dividing by 0, okay? All right, now I'm going to just do this for right now, okay? And watch what happens. Okay. Oh, I'm sorry. I have the wrong syntax. We have to say 0 as E. That's the correct syntax. Okay. So okay. So now you got this message. There was an error dividing by 0, but you still see that this line tried to execute the exception. The exception went down here, and then immediately there was this error dividing by 0, and then we never had a chance for it to try and execute this code right here. Okay. So the other thing that we can do is we can say, all right, in addition to catching these 0 division errors, we can catch the other type of error, which is the file not found error. Okay. File not found error is E. Okay. And I can say print file was not found. Okay. Now again, what do we think is going to happen here? Okay. The way the execute works is that we're going to try and execute this line. Okay. It's going to immediately detect a 0 division error. It's going to print out this error right here. Okay. And then it's going to jump past all the rest of this and just go to this next line. So even though I've added in this second exception type, I'm still not going to be able to actually execute this code. Okay. So let me show you that. All right. So yes, once again, we got there was an error dividing by 0. Okay. But we never got this file not found thing because again, it just skipped past all of it. Okay. All right. So then you have to ask yourself your question. All right. Well then, how do I deal with this? Okay. So I have a way to catch different types of exceptions, but if any one of them triggers, then it's going to just break me out of this and then start going into the exception handling. Okay. And so that's true. So what you might have to do is you might have to take this line and break it out into its own separate try except like we did earlier. Okay. But suppose that in this case, before this, let's go ahead and set C equal to a different number. Let's set C equal to 1. Okay. Now, if C is equal to 1, then when we execute this line right here, it's going to say, all right, B divided by C. So 3 divided by 1, that's just 3. So it should print out 3. Okay, so it's going to print out these 4. Then it's going to print out 3. Then it's going to get to this line. Okay, that file isn't there, so the code's going to then skip ahead over here. And now it should print out the file was not found. And then the execution will continue. Okay, and so let's go ahead and show that. Okay, and so sure enough, we see that in this case, it printed out those first 4 numbers. Okay, then it printed out divided by 1. Then it tried to open up that file and it said the file was not found, and then it continued executing the rest of the program. Okay. All right. So, all right. Now, the other thing that I want to point out is that with these try except blocks, okay, you can actually have 2 other things that go with them. You can have an else clause and you can have a finally clause. Okay. So the else clause executes if no exceptions are encountered. Okay. And the finally clause executes no matter what. This will always execute. Okay. So again, tracing through the flow of the program, what's going to happen is it's going to try and execute all of these statements in order inside this try block. I could have, thousands or 100 statements in here. I could have as many as I want inside this try, okay? If it encounters any error at any point in here, okay, then it's going to immediately stop running whichever line it's on in the try block. It's going to ignore all the rest of the lines underneath it. It's going to go find the except clause, which is the exception to deal with, okay? And then it's going to ignore this statement. There was an exception, so it will never execute this. And then it's going to print out this will always execute, okay? So let's go ahead and see what happens when we run this. All right, what we expect is we expect this to print out 3 divided by 1. So this should print out 3. Okay. Then we're going to try and open this file. This file doesn't exist, so it's going to jump down here. It's going to print the file was not found. It's not going to execute this statement because there was an exception. Okay, so it's not going to execute any of this code. And then finally always gets executed. So then it should say this will always execute. Okay, and so let's go ahead and verify that that in fact happens. Okay, and so sure enough, you see that it first printed out those first 4, and it printed out the 3 divided by 1. Then it said the file wasn't not found. Then it said this will always execute in that finally clause. Okay, over here. And then the program continued after that with all this. Okay. All right, so there's the try, except, else, and finally. All right, now suppose that I commented this out. Okay. So now I'm not trying to deal with the file. Okay. Now, what do we expect to happen? Okay. Well, when we try and execute this line, B is 3 and C is 1. So it'll just print out 3.0. Okay. Now I finished all of the tries in here, so there were no exceptions to catch. So this will be completely ignored. Okay. Because there were no exceptions caught, it will then execute this line right here. And again, this could be multiple lines. I just did one. And then lastly, it will execute this line. Okay. So what we expect is we expect to see 3.0. Then we expect to see there were no exceptions. And then this will always execute. Okay. So let's go ahead and save that and show that. All right. And sure enough, we see the 3.0, there were no exceptions. This will always execute. Okay. All right. So that is, I guess, kind of the basics for handling exceptions. All right. Now, all right. So does anybody have any questions about anything that I've gone over so far with regards to catching? So this is what I've gone over so far is how to deal with exceptions, how to write your programs so that they don't just crash anytime there's a problem, but instead you try and gracefully deal with, possible issues that you can run into. Okay, somebody says, would you please explain as E? Okay, yeah, so the as E, all right, E just basically assigns the actual instance of the exception into a variable called E. And E has different methods and attributes that we're not really going to mess with in this class. So you are correct in that I could just leave this out. Okay. What E does is that if there was some specific, like all of the stuff that you get, okay, when you actually get an exception, all this information right here, this stack trace and all this kind of stuff, that's actually saved inside the exception. Okay, so there's that E object has access to all of this should you want to print it out or otherwise deal with it. Okay, if you don't specify it and you just put in the colon like this, then you don't have access to all that stack trace information and you're then left to do whatever you want. So you're correct in that it will run perfectly fine without it. Okay. In this class, we're not going to really get into like the finer point doing exceptions. So are you to put in the as E if you don't want to? Okay, that's a good question. All right, any other questions?
Yeah, you don't have to use finally if you use else, right? Or do you?
Okay, so else and finally are completely different, right? Okay, else is only going to execute if none of these exception clauses hit. Okay, so if all of the code in here in the try block ran and there were no exceptions, then the else code is going to run. The finally code is going to run no matter what. Okay, so if I tried to do code and then there were some exceptions that were hit, it's going to do whatever's in here and then it's going to run the finally. Likewise, if I try and do the code and there were no exceptions, it'll do the else, but then it's also still going to do the finally. Okay. Now, finally is just kind of the same as if I took this code and just stuck it right here, like without it, right? This finally is equivalent to me just doing, okay, because again, this is going to execute no matter what, right? So it's basically the same thing. But finally is definitely not the same thing as else. Okay. Did that make sense the way I explained that?
Yeah, it did. It did.
Okay, great. Okay, any other questions? Okay. So now we're going to talk about cases where we might want to purposely cause an exception to handle, or to fire, okay? So far what we've talked about is we've talked about dealing with exceptions, but there's actually cases where we might want to actually cause an exception, okay? So let's go ahead and look at that for a second, all right? So I'm going to actually just create a completely new file. So I'll create a file called lecture 14. All right, and I'm going to get back into my object-oriented programming. All right, so I'm going to create a person class. We'll do def underscore init, and we'll do self, and then we'll do name and age. Okay, and we'll do self.name equals name, self.age equals age. Okay, so standard object-oriented stuff that we've done this whole semester. Okay, now I've said in the past that there are cases where you want to somehow restrict the kind of data and stuff that comes in here. All right. And because we hadn't covered exception handling, we've never really had a good way of really dealing with you know, people putting in the wrong kind of information. Okay. So let's say in this example, we only want to accept people whose ages are between, let's say, I don't know, it doesn't matter, 10 and 20 years old, okay? So in other words, if somebody tried to do P1 equals person, you know, and then they had Bob and they had 11, we should allow this object to be created, okay? But suppose that somebody tried to do Larry and they did, you know, 50, okay? Or more realistically, maybe we said, all right, we're going to have a person named Fred whose age is -8, okay? So obviously a person can't be -8 years old. That doesn't make any sense, okay? And so the point here is that we want to try and control the values that people are allowed to put in here when they actually create an instance of one of these people, okay? And so what we had done prior to today is we would put in something like, we'd say, okay, you know what, we're going to say like, you know, if age is less than 0, then we would like print, you know, invalid age or something like that. And then, you know, like else self.age equals age. Okay. But the problem is that none of this code actually prevents the person object from getting created. Okay. So in this case of Fred, right, Fred would still get created. His age wouldn't get set to -8, but his name would still be set to Fred. And we would still have this person object, you know, with the name of Fred and an age of, you know, 0, I guess, by default, would just be sort of sitting out here, not doing anything. Okay. And so what we want to do is we want to provide a way to basically not even allow that person object to be created. Okay. And so we can actually cause exceptions. Okay. It's called raising exceptions. All right. And so this is how we do it. Okay. We can basically say, all right, if the age is less than 0, then instead of just printing out a message and continuing, we're actually going to just crash the program. So we're going to raise an exception. All right. And you can use, we'll start out with just exception. All right. By the way, I'll go over this a little bit later if there's time. Python has a whole bunch of built-in exceptions, all right? And here's right from the Python documentation, okay? These are all the built-in exceptions. So you have like, there's the base exception, and then exception is a subclass of that. And then in here, we see some of the things that we've seen already that we've talked about. Like, so for example, here's the file not found error, okay, that we were looking at earlier. Okay, we've probably seen syntax errors and runtime errors and things like that. We have a value error. Okay, so yeah, the exception is right here. Let's see, the 0 division error. Here's the 0 division error right here. Okay, so we have all these different kind of built-in exceptions that we can use. Okay. But if we're lazy, and I'm lazy, we'll just go ahead and just use the general exception for right now, okay? Later, we'll talk into maybe using some different ones. Okay, so I'm just going to go ahead and raise an exception. And all of these exceptions, you can pass it a string that kind of gives it some information about the exception. Okay, so in this case, we'll say age cannot be negative. All right. Okay, and so now what I want to point out, I'm going to actually reorder this code a little bit. All right, so I'm going to try and create Bob. Okay, then I'm going to try and create Fred, and then I'm going to try and create Larry. All right, and just to be clear, I'm going to go ahead and add a stro method here really quick so that we can prove that things are happening. So we'll do return self.name plus comma age plus string self.age. Okay. All right. So now we have a person object. So I'm going to go ahead and print P1. Then I'm going to print P2. Okay. And then I'm going to print P3. All right. Okay. So what we expect to happen is we expect the first one, when we try and create Bob age 11, it'll get in here. It'll set the name to Bob. It's going to ignore this check because age is not less than 0. So then it'll set the age, and this is going to just create a normal object. Okay. When we get to Fred, okay, it's going to set the name, self.name is going to be set to Fred. The age is 0 or is less than 0. I'm sorry, because it's -8. So it should raise this exception. Okay. And now, well, let's watch what happens. Okay, so I'm going to save this. Lecture 14. Okay, so you see, it went ahead and printed out Bob age 11. And then, see how we got this exception. Age cannot be negative, and it gives you this whole backtrace. So it says that this error actually happened on line 15. Here's the code where it happened, and then further up, it was actually line 5. Okay, so in other words, we just crashed our own program. Okay, you'll notice if we go back here, all right, the first person got printed, but the second person, when we tried to create Fred with a negative age, it went here, raised this exception, and immediately crashed the program so that Larry never actually got created. Okay, you'll see that there was never any line that printed out Larry's, Larry, I guess, is 50. Okay, so we never saw a Larry age 50 line, okay, because the program crashed and died before it could even get to that point. Okay, and so how could we deal with this situation? Well, exactly the way that we just dealt with it earlier. Okay, so what I can do is I can put this line right here inside a try catch. Okay. Except it's not called catch, it's called except in Python. Okay, and I'm just going to put in exception. Oops, these are all in the wrong order. Okay, and then we'll say problem Fred. Okay, there we go. All right, so now we're going to try and create Fred with the negative age value. Okay, that's gonna bomb out and say, nope, I'm not even going to allow you to do that. But we're handling it here in our program so that our program doesn't just crash and die. And then it goes on and continues to create Larry. Okay, so let's go ahead and save this. All right, execute that. All right, and we see, so we got Bob age 11. Then we say, oh, there was a problem creating Fred because you tried to create Fred with this negative age. And then the program didn't just die on us. Okay, we handled it gracefully. We said, yep, there was a problem. And then we continued on with the program. Okay. All right. So this right here, you'll notice we actually caused our program to crash. But then over in here, we said, all right, we don't actually want our program to crash. We just want to prevent the programmer from going through and trying to create a person with a negative age. Okay. All right, so that is that. Okay, does anybody have any questions about what I've gone over so far? Questions, comments, concerns? Nope. Okay, nope. All right, I'm going to quickly run over the lab and the assignment. I posted those earlier this morning. I'm sorry that you don't have as much time to work on them, but I don't think anybody actually really starts working on them till about today anyway. So I made them, in my opinion, they're significantly shorter. I was able to complete both of them in less than 5 minutes. So I don't imagine that, you know, even if you take 10 times as long as me, it shouldn't take you more than an hour to get these done. Okay, so let's see. All right, so here's the lab, okay? So given this class, circle, okay, we've seen this class before that has the x, y, and the radius, okay? We're going to modify the constructor so that if x is less than 0 or greater than 499, then we're going to raise a value error. So before, we raised an exception, but in this case, usually if you're checking for values, you want to use value error. That's just kind of a convention, okay? But there's nothing saying that you have to, okay? If y is less than 0 or greater than 499, also raise a value error. And then if the radius is less than 0, is a different kind of exception, okay? So we're going to raise 2 different types of exceptions here inside this constructor, okay? So, I mean, I guess the big hint is kind of like what I just demonstrated here. This is sort of how you would do it, okay? Inside that circle class, okay? And then once we've done that, now we're going to add in the appropriate exception handling so that all of this code actually executes without crashing the program. So in other words, we're going to do what I just did here, okay? We're going to need to put in try except blocks to deal with the different types of errors, and you're going to need 2 different except blocks, right? You're going to need an except value error and an except exception in order to handle the different types of problems that you might encounter, okay, for each of these lines, okay? And so you'll notice that like this circle has a negative x value, this circle has a negative y value, this circle has a radius that's larger than 200, it's 250, and then this circle has it's got a negative x value, a y value that's too big, and a radius that's too big. Okay, so this one's really bad. Okay, so does that make sense to everybody, what I'm expecting you to do? It's essentially, I'm expecting you to do this. Just instead of a person, you're dealing with a circle, and you're going to need more try except blocks, and you're going to need a little bit more checking here in the constructor. Okay, is that clear enough? Okay, let me go over the assignment really quick. Okay, so there's one thing here in the assignment. Actually, before I go into the assignment, I want to demonstrate one more subject, which is, all right, I showed you earlier that there are all these different built-in exceptions, okay? But you can actually create your own, all right? And there's a lot of different ways you can do it, but for this class, I'm going to show you the absolute easiest way possible, okay? And then when I show this to you, then I'm going to talk about the assignment and I'll show you why we might want to do this, okay? So I think what I'll do here is, here I've just raised an exception, okay? But exception is pretty generic and it's not very specific to my problem, okay? Likewise, here in my catching, I'm just sort of catching any possible generic exception. So I'm actually going to create my own custom exception, okay? And I'm going to call this my negative age error, okay? All right, and this is going to be a subclass of exception, okay? So there, I made it a subclass of exception. All right, now here's a nice thing. You don't actually have to write any code. We're just going to put pass. Okay. Now you're asking yourself, well, why would I do that? Okay. Well, the reason is that when I'm writing my objects here, I might want to have very specific types of errors depending on the problem. Okay. So maybe in addition to a negative age error, let's suppose that I wanted to have a too old error. Okay. And again, this is a subclass of exception. Okay. Don't have to write any code. But in here, I can say, all right, so if the age is less than 0, I'm going to raise that exception. Okay. And then I'll say L if age is greater than, let's say, 120, because I don't think anybody lives to be that old. Then we'll raise a too old. Can't be that old. Okay. And we're going to change this exception to a negative age error. Okay. And so now the nice thing is that I can raise different exceptions based on the specific problem. Okay. And then I can have different ways of handling different problems. Okay. Maybe for a too old error, I might want to correct the, maybe just say, okay, well, I'm going to just make the guy's age 100 and then set it and continue, or maybe for the negative age error, I'll just say, okay, well, I'm still going to create this person, but I'll just give him an age of 0 or something like that. The point is that you can handle these different errors different ways depending on your program. Okay, I'm looking in the chat here. I see yes. So both the lab and homework. I don't think that the lab and the homework will take more than an hour each. I would be surprised if it took longer than that. Like I say, they both took me 5 minutes. I'm a reasonably fast typer, but 5 minutes is how long they took me. Okay. All right. So now that I have these different negative age error and too old error, when I go through and do my catching, again, I can say, all right, I want to catch the negative age error. Okay, and then here I can say, Fred is too young. And then I can catch the too old error. Say Fred is too old. Okay. And so if I do that, then you will see when I run this, okay, I get this Fred is too young. If I didn't actually catch this though, okay, like let's suppose that I just remove all of these, well, here, I'll create one at the end. I'll make a P. Liz, and we'll make her 300 years old. Okay, when I try and run this code, all right, it'll go ahead and work through all of this, but when I try to run Liz 300, you will see that the program crashes, and see how it raises this too old error. Okay, so I get this nice too old error, and then the message can't be that old. Okay, so this is using the custom exception that I create. Okay. All right. And so why might you want to do that? All right. Well, now let's take a look at the homework assignment. All right. So what we're going to do in this one is we're actually going to do a password validation system. Okay. So you're going to prompt the user to type in a password. Okay. And then you're going to check to see if the password has at least one letter, the password has at least one digit, and the length has to be, minimum of 6 characters, maximum of 12 characters. Okay. Then the last thing is kind of a red herring. This doesn't mean anything. It may or may not contain any other characters. So in other words, check anything. So the only things you need to check for are it has to have one letter, has to have one digit, and it has to be 6 to 12 characters. Okay. Now, I'm actually giving you the functions that you need to check to see whether or not a given password has a digit or has a letter. So you don't even need to come up with those on your own. There they are. You're welcome. Okay, that'll save you some time. Okay, and so this is what you have to do. All right, you're going to create a password class. This class should have a constructor and one attribute, password. The constructor should check for the above constraint and throw exceptions where appropriate. So in other words, in the constructor that accepts one argument, password, you're going to say, all right, if the password has digits, then it's good. Otherwise, raise an exception. If the password has letters, then great. Otherwise, throw an exception. If the password is less than 6 characters long or greater than 12 characters, then raise an exception. Okay? And so we're going to actually have 3 different exception classes: insufficient length, no digit, and no letter, that we're going to raise depending on the specific condition. Okay? All of these 3 child exception classes are going to look exactly like these guys up here. You just have to make sure that they're a subclass of exception, and you don't need to write any additional code. Okay? So that's a big hint. Don't go through and write a whole bunch of code. If you write a whole bunch of code, I'll know you didn't watch this lecture or that you weren't paying attention. Okay? So you should just have, insufficient length, pass. Class, no digit, exception, pass. All right? Okay, and so then your constructor of this password class will throw these different exceptions based on the checks that are gone. Okay, and then the last thing, all you're doing is you're creating a loop where you're going to basically keep on asking the user to enter in a password until they've entered a valid one. So as soon as the password is valid, in other words, it doesn't throw any exceptions, then we'll print out a message saying, okay, the password is valid. Okay, and so this menu is going to need to use a try except block to to handle the appropriate exception and print out a message. So here's what it looks like when you run it. So you enter this password. Okay, if you enter in 1, 2, 3, what I'm expecting to happen is that you will try to create an instance of the password object that you designed. That password object will raise an exception of, password length or what are we calling it? Insufficient length. So this should raise an insufficient length exception. Okay. And then you'll get this message right here when you handle it. And then it's going to go prompt you again to enter a different password. When you enter in that password, it'll try and create the password object. It does its checks. This password doesn't have any digits, so it prints out this message, prompts you again, enter in another password. So you put this one, it says, oh, that password doesn't have any letters in it, okay? Then this last one, okay, it says, all right, does it have digits? Yes. Does it have letters? Yes. Is it between 6 and 12 characters? Yes. All right, this is a valid password, okay? And then at that point, the program stops running. It doesn't prompt you for any more passwords, okay? So does that make sense? That's, again, I don't think that this should take you very long. You'll have to be a little bit creative on how you do the loop, and how you specify the conditions for like finishing the loop, okay? But at each stage, basically what you're doing is you're attempting to create a password object. So P1 equals password, and then you're going to pass in whatever the user typed, okay? That constructor of that password object should raise exceptions if it's not correct. If it raises exceptions, then you won't actually have an instance of the password object anywhere. It should print out some message, and then the loop should repeat, okay? Until they've actually entered in a valid one. All right, so I think that pretty well explains it. Does anybody have any questions about either the lab or the assignment that haven't already been asked? No questions? Okay, that's cool. One of the things that I want to, oh, somebody said the password without special character should be valid. Yes, you do not have to check for special characters, okay? In the original version of this assignment, I did not give you these functions and I did require you to do special characters and all that stuff, but that just made it a lot harder. And because I'm giving you this assignment so late, I removed all that stuff and made it a lot easier. Okay, so yes. So this password, like if we were to just remove the @ symbol, this would still be a valid password because it's still long enough. It still has digits and it still has letters. Okay, so yeah, good question. Okay, all right, so the last thing that I want to point out for tonight is, let me see.